this predicate will be true if we are choosing values of x and y from set of positive integers. I'm saying set of positive integers. Okay. So can we say that this predicate will always be true? The value of sum of x and y will be greater than equal to the first number x. Can I say like this? Can I say like this? What is your answer? Can we say like this? Example is, let us say this p of x comma y be a two-place predicate denoting x plus y greater than or equal to x, and domain is a set of all positive integers. Okay, it is z plus. Z is set of integers. If I am saying z plus, it will be set of positive integers. Will that be fine? Let us check. Okay, what is the first value? 1. Let us say x is 1, y is 1. 1 plus 1, 2. Whether 2 is greater than 1? Yes. Let us say x is 2, y is 1. 2 plus 1, 3. Whether 3 is greater than 2? Yes. Let us say x is 1, y is 4. Okay, 5. Whether 5 is greater than 1? Yes. Do you observe any counter example where this condition will be false? Do you observe any counter example? I suppose you will not observe any counter example for this, and this could be an example of for all x, for all y's, p of x comma y is true. Second case. Okay. What will be second case? How to read it? You are going to read it like this. There exists x, there exists y, for which p of x comma y is. So I'm not going to give you examples for this. Okay, I have given you example for first, and I'm interested in knowing the examples for this from your side. We are having 4 conditions. First condition is both are for all. Next condition is both are there exist. The third condition is one is for all, and next one is there exist. And the last condition, fourth one, is first one is there exist a value of x for all values of y such that p of x comma y is true. Can you tell me the answers for 2, 3, 4? Everywhere assume that there is a p of x comma y. I am not writing. Okay. So there also we will have p of x comma. I hope you have understood what I am trying to convey. The first equation is showing you for all x, for all y, p of x comma y should be true. In example, I have identified the example. Let p of x comma y be the predicate which says x plus y is greater than equal to x. Okay. And let us say domain is set of all positive integers. Then I can check out different possibilities. In each and every possibility, my p of x comma y is going to be true. In the similar manner, I want examples for 2, 3, and 4 from your side. Can you tell me the examples? If I am audible, okay. If this is visible, can you give me the example? For the second one, there exists x, there exists y, for which p of x comma y is true. This means that it is not true for all values of x and for all values of y, but for certain value of x and y, this predicate p of x comma y will be true. Are you getting, or it is something difficult to understand? I am not seeing any replies in the chat window. So whether my internet connection has gone or there is some lack in communication at your end. I am waiting for the answers. Yes, Rucha Khalate has given the answer. Okay. For second, x plus 1 is greater than equal to 1. X plus 1 is greater than equal to 1. There exists x and there exists y. Okay. 1 plus 1. Neha is saying x plus y greater than equal to 1. Yeah. Rucha, Neha's answer would be more relevant in comparison with your answer. Why? Because you are making the left hand side of your equation static by putting out the constant in the addition. So if you add up x and y and check out whether it is greater than equal to 1 for all integers, it would be true for some cases and it would be false for some cases. In that case, we would say that it satisfies the equation. There exists x, there exists y for which p of x comma y is true. In the simple case, okay, एवढं कॉम्प्लिकेटेड करायची गरज नाहीये. What is the simple example? X plus y equal to 3. When this x plus y will be equal to 3, whether it will be valid for all values of x and y? No. If I put value of x as 1 and value of y as 2, I will get the result as 3. If I put value of x as 2 and value of y as 1, then only I am going to get the result as 3. In only these two cases, I am going to have p of x comma y as true. In rest of the cases, it will be false. So this is an example of there exists a value of x, there exists a value of y for which p of x comma y is true. Am I clear? Is it fine? Boys, I'm not getting any answers. Okay, whether all are present? Yeah, fine. You are saying present, okay, but you are not answering. So anyone has got the answer for third situation? What is the third situation? For all values of x, there is at least one value of y for which p of x comma y is 2. Okay, do remember the third one and fourth one are totally different. How this is different? We are saying for any value of x, there is a value of y for which p of x comma y is 2. And what is the meaning of fourth one? There is a value of x for all values of y for which p of x comma y is true. Certainly it is different. That is the reason why I am asking you the examples. Meaning is altogether different. Okay, it is not at all same. I want some sort of logical thinking as we are studying the propositions and logic. Some thinking from your side. Otherwise, I am there to give the example. Okay, I am there to give the example. So, can you tell me the answer? Yeah. Any answers that you can give? Somebody has given. Okay, again, Neha is saying x plus y equal to 3. D is set of rational numbers. So, Athava is saying x square is greater than y. Think in terms of addition so that your understanding will be more fine. Okay, I'm not saying the other examples will not hold, but if you are thinking in terms of addition, you would have greater understanding. Perhaps I have discussed some example yesterday, I guess, related with this. Okay. For all values of x, there is a value of y for which this p of x comma y is true. Okay. What to say? I think I have discussed this. Let me open my notepad. Here there is a difficulty in typing. Okay. So if I say let a equal to 1 comma 2 comma 3 comma 4 and p of x comma y be a predicate, it says x plus y equal to 5. How would you represent this? Okay. Can we represent it using the third condition which we are seeing? For all x, there is at least one y. Okay. So if my value of x is 1, which value should I choose? There is at least one value of y. So I will say 4. In order to have p of x comma y as 2. If I am putting value of x as a 2, there is at least one value of y for which it is 2. If I am putting 3, I have to pick up 2. If I am putting 4, I have to pick up 1. This is the meaning of this statement. Okay, this statement. We have discussed this. For all values of x, there is at least one value of y for which the given predicate P of x comma y is true. I hope now it is clear. Yes, Kunika, x plus y equal to 0, domain is real numbers. Yeah, yeah, yeah. X plus y equal to 0, domain is real numbers, and we are putting okay real numbers. So if I'm saying 0.1 plus 0.2, the result is 0.3. Okay. Yeah, yeah. But we are talking about yeah for all x and their existence. Very nice, very nice. Okay. Yeah, yeah. You can put negatives, and in that case, it will come up to 0. Yeah, yeah, yeah. Brazil is saying x square is less than x. Domain consists of real numbers. Perfectly fine. Yes, such thinking capabilities must be developed in your mindset. Okay, very good, very nice. All your answers are also correct, and my answer is also correct. Okay, whatever I am giving. Now I will not give any answer for 4. Take this as a homework, or if you want to take it now, you can tell me the answer. Okay. There exists a value of x for all values of y. This is different than this. I am repeatedly saying there exists a value of x for all values of y. Meaning is there should be exactly one value. Okay, at least one value which is valid for all values of y in order to have result as 2. Fourth one, can you think of there exists x for all values of y such that p of x comma y is 2. Okay, take this as a homework. You can take a snapshot of the slide. We will move ahead. Okay, no problem. No problem. We'll move ahead. Okay. Okay. Fine. Who is saying Abhishek Hamkar? You are telling about fourth one, x plus y equal to y. Only one value of x. Okay. Yeah. Certainly yes. If you are taking 0 as x, isn't it? If we are adding any number with 0, obviously our result is going to be the same number, isn't it? So certainly it is absolutely correct. X plus y equal to y. There is always x as a 0 for all values of y. Okay. What I want to say, there exists a x which is 0 for any value of y. Y could be any integer. Then if we are having p of x comma y as x plus y equal to y, then you would say that this is perfectly fine. What do you think? Yes, is it fine? Omkar is saying x plus y greater than y. Omkar, okay, again you need to define which domain you are considering. What is the domain for your example? If you are talking about x plus y greater than y, what is the domain? All integer. You are wrong. How you are wrong? Can you tell me? If you are saying all integer, you are wrong. Recently, I have explained this with the help of Abhishek's example. He is saying x plus y equal to y, isn't it? So if we assume x as a 0, okay, 0 is coming under all integers. If I am saying 0 plus any y, okay, whether y is greater than y, no, you should write your equation like x plus y greater than equal to y. Now you are saying except 0. Oh, you are getting this. Except 0. Oh, okay, fine. Okay. So today's point of discussion. Who is saying something? Mangesh or Mahesh? Mahesh Kangude. Natural number. Okay. We are going to see what are the sets of natural numbers and everything in this set here in the due course of time. I will revise whatever you have studied in your mathematics, nothing else. So moving ahead for the next concept, logical implication. Okay. Prepositions. A and B are said to be implicable, logically implicable, denoted as A. These are okay. This is the notation for logical implication. A logically implies B if and only if A conditional B is a tautology. So we need to check whether A and B are logically implicable. If they are logically, we would say equivalent implicable. Okay, logically equivalent. If we are getting A conditional B as a tautology, that's fine. A new concept. Its symbol is A. This arrow B. Okay. Next, moving further, let us say an example. Okay, what is the example? Uh, Let me check out for A. B conjunction Q. Okay. Let us check for this whether this is logically implication is fine or not. P conjunction Q logically implies Q. How we are going to prove that this statement is true? You are going to construct a truth table. You are going to construct a truth table for P conjunction Q, whole implies Q. And if all the values in the last column are true, if that is a tautology, you will say that P conditional Q logically implies with Q. That's fine. Right. What's happening? Somebody is trying to get Atul, Bhut, Alia Bhut. Whether Alia is your classmate? I have not seen her any time. Whether Alia Bhatt is your classmate? Anybody can reply in the chat window. I'm observing that many students from other colleges are also joining our class. Okay, that is the reason why I'm asking whether Alia is your classmate. Any replies? Anyone who is fan? Don't know. Okay. So see, the students from Pune. Yes, she is an actress. Okay. So why that actress would not be your classmate? Would be okay. No. Other college students are also joining. That is the reason I'm taking care. Nothing else. Okay. So P Q P conjunction Q P conjunction Q conditional Q P P F F P F P F P P P P F F F P F F F F. And if you take conditional what of what? This with this T T T F F T F T T F F T. If this last column entries are all true, we are saying it as a tautology. So we could say that P conjunction Q is logically implicable on Q. The definition of logical implication. Examples for you as a homework. So first example, this is visible. Two examples for your practice. Again, take a snapshot and check out. You will be constructing a truth table and checking whether the last column entries are all true. If so, we will say that it is a logical implication. One last thing, okay, one last example on this logical implication. But again, you are going to solve, not me. P to Q. So I hope you have taken the snapshot of this. We are going to solve this for today. Okay. The small mistake in the last example. Now you can again retake the snapshot. P to Q, pole implies P to R. The logical implication you need to prove. Have you taken? Shall we proceed? Yes. Okay. One more thing. Okay. You are joining this class online lectures using the classroom link. And if all the members of SC Computer are present in the classroom, you should not share this classroom link or neither a meeting link with any of your friends. Not here. If he or she is interested in attending the lectures, only thing is he or she should take a prior permission of me. I will not say do not attend the lectures of mine if you are not in this college, but you should concern me before attending. No direct entry is allowed. Okay. Next. So, have you taken this? Okay, let me save it. Let me see two. New. Good. Next is definition of valid argument. So when we are saying a given argument, whatever we are discussing so far or we used to discuss with our friends, okay, how can we validate if something is true, whether something stated is correct or incorrect? There should be some prior definitions, methodology for checking out whether the statement or the argument is valid or invalid. Okay. So what do you mean by valid argument? This valid argument will be a finite sequence of propositions P1, P2, Ashish, do you have any problem? Ashish Marathi, who is he? Okay. Finite sequence of prepositions P1, P2, P3 up to P of n, called as hypothesis oblique premises, together with statement we are checking out the definition of finite together with a statement capital C known as conclusion, such that premises so for checking out the validity of given arguments and the final conclusion, we are saying that an argument, a sequence of statements would be said to be valid if I can represent that argument in the finite sequence of prepositions P1, P2, P3 up to P of n, which are called as hypothesis or premises, together with the statement conclusion, such that if we take conjunction of premises, conditional conclusion, that entire result is a tautology. I am going to take the example so that your things would get clear. Okay. Uh, so for a while, just try to get with the definition of valid argument. And again, an obvious question could come in your mind, why we are learning this. So whenever we are writing a computer program using any of the programming languages, you need to provide a validity of that computer program, whether that program is valid, whether it works in the uniform way for the all inputs, whether it is going to produce the correct output for each and every case of input. In that case, you would require the understanding of validity of an argument. Okay. It should not be a case that your program is working fine. Let us say addition of two numbers, it is returning 5 if I supply two parameters 2 and 3. But at the other time, if I am executing my program and passing parameters as 11 and 12, and it is giving me some wrong result of addition, it should not be a case. So we will say that a program is valid if we can represent the various states of a program in the form of such premises together with the final output, that is conclusion. So I'm trying to say a finite sequence of prepositions from P1 to Pn, these will be said to be hypothesis of or premises together with the statement some conclusion C, such that conjunction of premises conditional conclusion is a tautology. If that holds true, then we are saying that it is valid. Before going for the actual examples of this validity of arguments, let me discuss the very simple example in the real-time context, so that you would say that it is perfectly fine, that whatever we are discussing is making a sense, or if it doesn't make a sense as such. But if I'm saying Virat is brother of Kunal and if Kunal is brother of Ashish, what will be your conclusion on the basis of this statement? Virat is brother of Kunal and Kunal is brother of Ashish. What will be your conclusion? Can I write like this? Virat is brother of. How we are able to have this conclusion? We are able to have this conclusion because we know that these are the facts, these are the some hypotheses or premises which are being given. The first premise given is Virat is brother of Kunal, and second premise is given as Kunal is brother of Ashish. If these two conditions are true, if Virat is brother of Kunal as well as Kunal is brother of Ashish, obviously we can conclude that Virat is brother of Ashish. It is just like saying if X is related with Y and Y is related with Z, I can come to a conclusion that X is related with Z. Okay. Okay. One more example before I start with the actual examples. Okay. There is a road from Varanasi. There is a road from based on this, if you have been given provided with this information, what will be your conclusion? If we are knowing this, there exists a road from Varanasi to Murgaon and Murgaon to Pune, we can arrive at a conclusion that there exists a road from Varanasi to. How we arrive at this? We would say that whatever I am making, this entire set of statements is valid. How come valid? Because if this is true, if there exists a road from Varanasi to Murgaon, and again, if this is true, Murgaon to Pune road also exists, then obviously your conclusion, what is the conclusion? There exists a direct path, road from Varanasi to Pune. This will also be true. So how we are defining? We are defining finite sequence of prepositions called as hypothesis or premises together with conclusion such that conjunction of premises and its conditional is tautology. So I will say this is P1, this one is P2, and therefore conclusion, this one is conclusion. Okay, we come to know about this fact that all are true. Okay, and as per the definition of validity, we are taking conjunction of premises conditional with conclusion. What is the result of P and T? T. T conditional T. Again, your final result is P. That is a tautology. So if this is a tautology, I will say that whatever the statements I am making is a valid argument. Am I clear? Am I clear? Is it fine? Am I clear? Okay. Observing that a few people are leaving and again joining the meeting. Whether there is any problem at your end, I do not know if there is a problem at my end. Suppose there is no problem at my end. Okay. Everything is going smooth here. Okay. Now I am at here. So there are few laws or theorems in the notion of determining the validity of argument. Okay, so the law number one. These laws will help you to determine whether the given set of statements or propositions are valid or invalid. You would have again a question. We are having this definition. Okay, we are having this definition. We can directly check out whether the given set of statements are valid or not using the formula conjunction of premises conditional conclusion. But you need to construct a truth table and it will take a time. So what is the alternative? We can try to relate given statements in these laws. If we are able to relate given statements in these laws, we can directly write the given set of statements are valid using these theorems. So law number one, modius ponens, also known as law of detachment. Modius ponens. Okay, what this law says? The law says that if you have been given a premise P to Q and the other premise is P, okay, if this is given, then we can arrive at a conclusion. If we know that P conditional Q is true, P is also true, what will be our conclusion? Conclusion will be Q. Okay. Try to understand what I am writing. Okay, this is premise 1, proposition 1. This is proposition 2, and this is your conclusion. This is the law of detachment. Okay. Whether it is valid argument, it constitutes a valid argument because if I am writing this as this P conditional Q conjunction P. Okay. Whole conditional Q, I would get that is a tautology. If it is a tautology, obviously whatever we are discussing is a valid argument. Good, fine. I'm quite sure that you are getting something in confusion. Okay, with respect to this. So let me take the example for this. Very simple example. Okay, if I say if Virat gets a first class, he will get a new bike. This is the first statement. If Virat gets a first class, comma, he will get a new bike. Next statement, Virat gets a first class. Therefore, what is your conclusion? If I am saying we have been given a statement like this, if Virat gets a first class, he will get a new bike. Virat gets first class. therefore. So whatever is therefore, that is your conclusion that you are writing after this horizontal line. If this happens, then this is going to happen. That is the meaning of it. Therefore, what is the conclusion? Virat gets a new bike. Can I relate this with this law? So what is the first? First premise should be in the form of P conditional Q. So this is in the form of P conditional Q, wherein our P is Virat gets a first class, while Q is Virat will get a new bike. Okay. So the first premise is represented in this format. Then we are having second premise, Virat gets a first class. That is P, P2. Okay. What is the conclusion? Conclusion is Q. So do we have Q only here? Virat gets a new bike. So we can directly say by reading these statements using the law of modus ponens or law of detachment, the given set of arguments is valid. Whether it is making any sense, whatever I am discussing, or it is creating a confusion in your mind, whether it is making a sense. Otherwise, it would be a thing that okay, you are having some problems at the back end. Does it make a sense? Whether it is difficult, are you finding it difficult? You are answering yes for easy or difficult. I am asking whether it is easy or difficult. Okay. Fine. If it is easy, let me go ahead. Okay. So this was the example for first. As the recording will be available, okay. No need of taking the snapshots. You can go through the recording one more time for checking out each and every possibility. Nothing else. So first law I have discussed. Now let me go for law number 2. Law number 2, say it is modus ponens, also known as law of contraposition. This is represented like this, modus ponens. If you are having P to Q as a first premise and I am having negation of Q as a second premise, and if both are holding, then what will be my conclusion? Can anybody tell me in chat window? We are having this law, but can you infer what should be conclusion? If these are the two premises, if P to Q holds and we are having negation Q, what should be the result in the conclusion? What should we have in conclusion? Negation Q, very nice. Okay, Akshara is saying negation Q is given. Akshara, negation Q is given. Yeah, negation P should be there. Very nice. Very nice. Absolutely yes. So this is the law of contraposition. So if we are having two premises in this format, one is P conditional Q and other one is negation of Q, then the final conclusion will be negation of P. Vaibhav, are you ready? Okay, good. Good. Now, any one of you is going to unmute your mic and tell me the example in the statement format for this. Okay, in the statement format, anybody can unmute the mic and tell me the example in the statement form. Be fast. Nobody is unmuting. So the example in the statement format for this will be, if Virat gets a first class, he will get a new bike as it is. And we will have here, Virat does not get a new bike. Virat doesn't get a new bike. Therefore, Virat doesn't get a first class. Are you ready? This example will slightly change over here. This will not be as it is. I need to slightly change it. So first statement will remain as it is, and here you are going to have changes. So what changes? Virat doesn't get a new bike. What is the conclusion? Why Virat is not getting a new bike? As Virat has not got distinction. or first class, whatever. I hope I'm clear. But fine. Why this is going to happen? This will happen because of this. Virat gets okay. It's fine. I'm going to give you examples as an exercise. Okay, once I finish with few more laws. Okay. Technical metal has already waiting. Okay, who is technical metal? Law number 3. Disjunctive syllogism. Law number 3. Disjunctive syllogism. Okay, what it says? If we are having a premise in the form P or Q, the other premise in the form negation of P, what will be your conclusion? What is the conclusion? So that it is or, it is not conditional now. So how would you have a negation of Q? It should be Q. It is validity. We are checking validity of arguments. Q, only Q. Why Q? Why not negation of Q? Let us take an example. Why it is Q and why not negation? Either it is sunny or raining outside. This is my example. Okay. It is not sunny. Therefore, what is the conclusion? It is given that either it is sunny or raining. Either of the things can happen, but not both. Exclusive or. Okay. Either it is sunny or raining outside, but not both. It is not sunny. That is negation of P. Then what is the conclusion? It is raining outside. Does it make a sense? So first line, this first statement, this one will be present P or Q. This is it is not sunny, opposite of first. If we assume P as a preposition which is saying it is sunny, its opposite will be it is not sunny. Negation of P. So what is the conclusion? Therefore it is raining outside. Am I clear? Disjunctive syllogism. Whether it is fine? Whether it is fine? Yes. If you are saying yes and others are gone somewhere, you should have a habit of okay, fine. Law number 4. You know that as in comparison with earlier lectures, I am going a little bit faster for this lecture, just to maintain the pace of unit completion as well as the pace. The total duration of lecture is minimized to 45 minutes in comparison with 1 hour. So, still, if anything is not clear, let me know. Next is hypothetical syllogism. Law number 4. We are having only 4 laws. Okay? So this is the final law. So P to Q. Second one is Q to R. These are the 2 premises given. And what will be my conclusion? If P to Q and Q to R are known, then our conclusion will be P to. This is our conclusion. Okay. P to R. Very nice, actually. Good. So this is hypothetical syllogism. Can you type in the chat window the example for this hypothetical syllogism? Can you type in chat window? Okay, I will tell. I'm not waiting for your answers. Okay. If Virat studies hard, then he will get a distinction. If Virat gets distinction, then he will get a new bike. These are my 2 statements. First statement, I said if Virat studies hard, then he will get a distinction. If Virat gets a distinction, then he will get a new bike. Next, I am saying Virat studies hard, therefore, okay, what is the conclusion? Therefore, if Virat studies hard, then he will get a new bike. Ready? Very fine. Am I audible? Whether it is clear? We are saying first statement as if Virat studies hard, then he will get a distinction. If Virat gets a distinction, then he will get a new bike. Therefore, the conclusion is if Virat studies hard, he will get a new bike. This can be related using hypothetical syllogism. If there is a corona, there is a holiday. No holiday, there is work from home, you can say, for students. Okay. If there is a corona, we are at home. What Abhishek is saying, if there is a corona, there is a holiday. If there is a holiday, we are at home. Therefore, if there is a corona, we are at home. Very nice. Okay, okay, fine, fine, fine. So, just before I conclude, I have one example for you that you are going to immediately solve and let me know whether this is valid or not. If Gita goes to class, she eats on a time. Gita eats late. Therefore, she will miss the class. Whether this entire argument is valid or invalid and using which law, that you are going to tell me. Take your time. We are having 5 more minutes. Okay, I'm taking your time of break, but I think taking a time of break should not hamper any of your other activities. Okay. We are learning something new, so it should be interesting. Valid. Second, Neha is saying second. Second, which law? Law of contraposition. Very nice. Correct. So these set of statements are valid using the law of contraposition, also known as modus ponens. So first statement says Gita goes to class, she is on time, P conditional Q. Gita is late, she is not on time, that is negation of Q. Therefore, what is the conclusion? Negation of. So I can represent this like this, P to Q. Negation of T. So the conclusion is negation of T. Law of Tonens. Is it fine? Whether it is clear to all of you? Whether it is clear to all of you? So would you practice few examples if I post on your classroom? Would it be interesting to solve? Okay. So see, if we are not able to determine any law out of these 4 laws, we are having this definition. So we will do what? If we are not able to determine any law, we are writing the given argument in terms of premises. Then we are writing below the horizontal line the final conclusion. We will construct a truth table for all premises, conjunction, conditional, conclusion, and we have to check whether the final result is a tautology. Are you ready? Some arguments can be directly placed in these laws, while some arguments may not be placed in these laws. So you need to try accordingly. Okay. Other things in Monday lecture, before we stop for today. Okay, before we stop for today, again the same thing that we are carrying out every time. Okay, so all of you are going to turn on your cams and we will have some smiling faces on the cam. Okay. So can you turn on your cam? Be quick. Yeah. You are only turning on the cam. Okay. What to do next? Yeah. Whether it is like this or this, like this. Okay. Okay, fine, fine. So we are about to finish part A from unit number 1. I will be finishing on Monday in the logic and prepositions part. If anything need to be repeated, if anything is not clear, let me know. Next, I am going to start with mathematical induction from Tuesday onwards. Okay. Thank you for today. Have a great day ahead. Now you can leave the class. Okay. Thank you.